Okay, class, the last basic feature on a weather map that we're going to talk about are warm fronts. Okay? And warm fronts are on a weather map are going to be red lines with red semicircles that point into the direction that the warm, moist air is moving. If we draw this in 3 dimensions, it's going to look something like this. Okay, so here we've got warm, moist air. And they being warmer and moister, once again, it's going to be less dense. And this wedge right here is going to be represented by colder, drier air. So if it's colder and it's drier, it's going to be more dense. So colder, drier, more dense air. All right, and so the front itself, the warm front, that red line, is going to be the boundary. So this front, this warm front, just like with the cold front, the front is a boundary separating air with different density. Separating air with different densities. Because they have different densities, again, they're not going to want to mix. So this warmer moisture, and the reason it's called a warm front is, in this particular case, it's the warm moist air that's doing the advancing. Okay, so I know sometimes we think about kind of the cold, dry, dense air is kind of the bully. It's, you know, being denser, it just has its way with the warm, moist air, forcing it to rise. Well, that's not the case. The warm, moist air can be the aggressor. It can be the air that's doing the advancing. But in this particular case, well, not in this particular case, but it doesn't matter whether the cold, dry air doing the advancing or the warm, moist air doing the advancing. Whatever air is less dense, and that's going to be the warmer, moister air, that's going to be the air that's going to rise. Okay, so being less dense, the advancing warm air, warm, moist air is going to ride up on top of the colder, denser air, colder, drier, denser air. Okay, so, you know, if we look at it this way, the warm, moist air is doing the advancing. It gets to the front where you got this wedge of colder, drier air, and that warm, moist air is going to be forced to rise. Okay. Okay. And so we should make that point then. So being denser, the warm, moist air is forced to rise. Okay. And this is another example of frontal wedging. So we got cold frontal wedging and we've got warm frontal wedging. In both cases, it's the cold air that creates the wedge, okay, and the warm, moist air is going to do the rising. Okay? And again, anytime you get rising air, this means that the water vapor will be carried up into the atmosphere. Okay. And when we carry the water vapor up into the atmosphere, the result is that you're often going to get clouds. And if there's enough water vapor to work with, you're going to get precipitation. So clouds and precipitation. So fronts, no matter whether they're warm fronts or cold fronts, are often going to be locations of clouds and precipitation. Now the difference, there's a couple of big differences between the clouds and precipitation associated with cold fronts and warm fronts. One is the proximity of the clouds and precipitation to the front. So remember, with cold fronts, the clouds and precipitation were in close proximity to the location of the front. In this particular case, you've got to give the warm, moist air time to ride up over the back of this wedge, almost piggyback style. And it's the slope of that wedge is not going to be as great as it is with the cold front. And so your clouds are going to be not developed as deeply or as high up in the atmosphere. Okay, and you're also going to get usually, not always, again, there's no absolutes in meteorology, but there's less of a chance of severe weather. So with warm fronts, the clouds and precipitation are typically out ahead of the warm front. In other words, they're not in close proximity to the warm front. All right, and again, because the clouds aren't as well developed in terms of thickness, you're probably going to get more drizzly type precipitation, less intense. The precipitation will be oftentimes less intense with warm fronts. But, you know, that being said, I've seen plenty of wonderful thunderstorms develop associated with warm fronts. So there, again, there's no absolutes. I'm talking about in general terms here. Generally, the clouds are not as well developed, and the intensity of the rain is not as great with warm fronts. Okay, so next what we're going to do is we're going to take a look at, now that we've taken a look at what are the basic features on a weather map, how do you know that everything is, how do you know that the fronts are where they are? How do you know that there's that low pressure? How do you know that that's located there on the weather map? How do you know that that high pressure, that big blue H, is located where it is? How do you know where to draw those isobars? So that's what we're going to talk about next.